Hello, calculus students and general seekers of truth. Welcome to the lesson on parametric equations and calculus. Now, before we get to the calculus, let's just review parametric equations so our minds are a little bit more fresh when it comes to this. The idea behind a parametric curve is that you have three variables involved now. T, which is called the parameter, and it usually represents time, x, which is the x-coordinate, and then y, which is the y-coordinate. But x and y change with respect to t. And this is very much like real life. You could have a particle that runs along some sort of path that's two-dimensional, and it changes the x-coordinate and the y-coordinate of this particular particle changes as time changes. Okay? But let's look at a very abstract example. Here we have t going between -2 and +3, so it's not exactly practical, although there are some meanings that we could use for it. But let's just get some practice writing this. So let's see. So we just make a table of values. The question asks for t between -2 and +3. So let's start. Now, if t is equal to -2, then x would be -2 squared, which is 4, minus 4, which is 0, and y would be equal to -1. Okay. So in this case, you have, and I'll do this in color, 0, -1 is this point there, and that's where t is equal to -2. And then if we keep on going, let's see. If t is equal to, let's go to -1, then x is going to be equal to -3, and y is going to be equal to -half. So it's like this is -2, this is -4, -3, -half is like right here, and that's where t is equal to -1. And I'm going by increments of 1 here because it's a little bit easier to calculate, but you certainly don't have to. When t is equal to 0, x is -4, and y is equal to 0. And then when t is equal, I'm just going to hit pause on the video, keep going, and fill out the rest of this. I recommend you do the same and then compare your answers to mine. Okay, so once I'm done graphing all the points, I get this picture here. And if you look at this picture and just kind of follow the dots as they move, you can see that we're going to have like this sideways parabola here. Okay. And we also want to use some arrows to indicate the direction. In other words, we don't know whether the object is going this way or this other way if we don't use the arrows. In this case, we started out, you can see that when t is a small value, it's over here, and as t increases, it actually moves along this path. So just use a couple arrows here, 3 arrows altogether, that indicates the path of this graph. And again, practically, this could represent the path of some particle or some object that moves in this way. And not only does this allow us to graph equations that are not functions, but it also allows us to incorporate the parameter t and understand a little bit more about how the graph changes as time moves on. Okay. Now, often it is the case that we want to, in addition to solving the problem, we want to find a relation between x and y. So that's what this term is used for, to eliminate the parameter t. Sometimes they don't specify t, but you can assume that it is the parameter. And the idea behind the eliminating the parameter is solve one equation for t and then substitute into the other. Okay. So we have 2 equations here, one relating x and t, and one relating y and t. You solve one of them for t, and then substitute it into the other. So I'm just going to write it over here. And in this case, I'm going to solve for the y equation because that looks a little bit simpler. So 2y is equal to t, and using this equation here. And then I can take this and substitute it in for the x. X is equal to t squared minus 4. But we know that t is equal to 2y. So then once we expand this, we can say that our x is equal to 4y squared minus 4. Okay. And there you have it. This kind of sums up, how to use and graph a parametric graph.